Morning, student. We had discussed what is group theory, and we had discussed syllabus of this paper one by one. M.Sc final syllabus, unit first, second, unit third, unit fourth, unit fifth, and after this, I had suggested a book of F.A. Cotton for application of group theory in chemistry, chemical application of group theory. I've forgotten. What is symmetry? We had discussed. After this, what is symmetry element? Molecular symmetry we had discussed. Element of symmetry and symmetry operations. If any operation is carried out over a entity present in molecule, and if it results in indistinguishable configuration, then the entity is referred as element of symmetry, and operation that is carried out over the entity is termed as symmetry operation. Symmetry elements are there on this scheme: axis of symmetry, or proper axis of symmetry, or n-fold axis of symmetry, plane of symmetry or sigma plane, center of symmetry or invergent center, improper axis of symmetry, or n-fold alternate axis of symmetry. Then now we will discuss one by one each element of symmetry. First of all, I would like to share axis of symmetry. What is axis of symmetry? An axis passing through a molecule over which a rotation of an angle of 2 pi by n, if results in indistinguishable configuration, then it is termed as axis of symmetry. Axis of symmetry. In BF3 molecule, BF3 molecule is a planar molecule. It has C3 axis. Which axis is 3 axis? This is the axis. This one will be this axis. This axis is C3 axis. How it is C3 axis? This axis is perpendicular to the molecular plane, and if BF3 molecule is rotated about an angle of 120 degree, then what happens? This F1 will come to F2, this F2 will come to F3, and F3 will come to F1. Then it is indistinguishable configuration. In which way it is indistinguishable configuration? At the place of fluorine, you will find fluorine. At the place of boron, you will find boron. Therefore, it is indistinguishable configuration, and we can say this axis is element of symmetry, or axis of symmetry, or n-fold axis of symmetry. As 120 degree rotation results in indistinguishable configuration, therefore it is C3 axis. 360 by 120, it is equal to 3. Therefore, order of this axis is 3, or we can say it is threefold axis of symmetry. Here you can see C31. It is first rotation, therefore it is superscript is 1. After this second rotation, therefore it is C32. 120-degree rotation again results in indistinguishable configuration. Next rotation, that is C33. 120-degree rotation again result in exactly similar configuration. That is the configuration through which we had started. Therefore, we can say it is called, the final is exactly similar configuration and it is called identity. And C33, which rotation or which operation results in identity or exactly similar or original configuration, that is called identity operation. So C31 is not identity operation, C32 is not identity operation, but C33 is identity operation. It is identity operation. Similar way, in water also, you can see that there is a C2 axis. In water, there is a C2 axis. As you know, water is V-shaped molecule, and at the top, oxygen is present, and at the corner of V, two hydrogens are present. Axis passing through oxygen and in between two hydrogen atoms is axis of symmetry. Why it is axis of symmetry? Because if molecule is rotated by an angle of 180 degree, then indistinguishable configuration will result. At the place of hydrogen, hydrogen will be there. At the place of oxygen, oxygen will be there. Therefore, we can say the axis that is passing through oxygen and that is present in molecular plane is C2 axis, and C22 in water is identity operation, because C22 operation results in exactly original or similar configuration. Original configuration. It results in original configuration. Therefore, it is identity operation. In water, C22 is identity operation. What about BF3 molecule? Any other axis of symmetry are present or not? In B3 molecule, along with three along with C3 axes, there are C2 axes are present. You can see here the axis passing through, that is first C21. The axis passing through boron and one of the fluorine is C2 axis, because if molecule is rotated by an angle of 180 degree, it will result in indistinguishable configuration. These C2 axes are present in plane of BF3 molecule. C3 axis was present in perpendicular plane, while C2 axes are present in plane of BF3 molecule. And there are three C2 axes. Each axis each C2 axis passing through one of the fluorine and boron, and all the C2 axes are present in plane of the BF3 molecule. Thus, in BF3 molecule, two, type, two types of axes are present. One is C2 axis and another is C3 axis. If two or more axes of symmetry are present in a molecule, then axis with higher fold or axis of higher order. There are two order, 2 and 3, C2 and C3. Therefore, the axis with higher order is termed as principal axis. Thus, in BF3 molecule, C3 is principal axis and it is present in perpendicular plane. So, it is clear that if axis of higher fold is termed as principal axis. Can you visualize axes in benzene molecule? You know, benzene molecule is again a planar molecule, and all the hydrogen and carbon are present in the same plane. In this molecule, a perpendicular axis that is passing through center of the molecule, not from any atom, it is passing through center of the molecule. And if benzene molecule is rotated through this perpendicular central axis by an angle of 60 degrees, then it will result in indistanceable configuration. It will result in indistanceable configuration. Thus, we can say that benzene molecule has C6 axis or axis of symmetry. Why C6? As you know, 360 by 60 is equal to 6. Then order of axis is 6, or it is 6-fold axis of symmetry. It is 6-fold axis of symmetry. The benzene molecule is a symmetric molecule as it has element of symmetry. In benzene molecule, other axes are also present. That is, the C6 axis itself is C3 axis. That is, if molecule is rotated by an angle of 120 degree, then also indistanceable configuration will result. Therefore, we will say that the C6 axis coincide with C3 axis, and C6, C6 and C33 in benzene molecule are identity operations. With C6 and C3, C2 axes are also present in benzene molecule. These C2 axes are present in plane of the molecule. You know, the axis that is present at opposite corners of hexagon Axes passing through opposite corners of hexagon are C2 axes. As if molecule is rotated about an angle of 180 degree around this axis, then indistinguishable configuration will result. Therefore, these are C2 axes. C6, C3 axes are present perpendicular to the plane, while C2 axes are present in plane of the molecule. Therefore, in benzene molecule, there are three axes of different order: order of 6, order of 3, and order of 2. And you know, highest order is 6. Therefore, C6 axis in benzene is principal axis. In benzene, C6 molecule is C6 axis is principal axis because it is of highest fold, it is of 6 fold, therefore it is principal axis. With this, we will conclude it here only. Axis of symmetry, the axis through which a molecule is rotated by an angle of 2 pi by n, and if it result in indistinguishable configuration, then this axis will regard as axis of symmetry. And what is principal axis? Axis of highest fold is termed as principal axis. Next we will discuss in next class.